Let's now look at another example question which relates to null space as well as inner product space. So in this question, we are given a matrix A, which is m times n, and we want to prove that if B is a non-zero vector in the null space of AT, then the system of linear equation AX equals to B has no solution. This question is quite tricky because in order to prove this, we can't prove it using conventional methods. We have to use a technique called proof by contradiction. So what this technique does is that what we're trying to prove is that AX equals to B has no solution. So instead of trying to prove that, we first assume AX equals to B has a solution. And from this assumption, then we try to derive some kind of contradiction, some ridiculous contradiction. And since the contradiction is logically wrong and shouldn't happen, that just means that our basic assumption that lead us to the contradiction is also wrong. So that means that our assumption that AX equals to B will be wrong, and therefore AX to B equals to B has no solution. So to begin with that, so first we notice that B is in the null space of AT, which then means that AT times B gives you 0. Since any vector in the null space of AT get multiplied by AT will give 0. And then if we take transpose of both sides, then we have ATB transpose equals to 0 transpose, and we can use the property of transpose to put this transpose into the bracket, but we have to switch the position of the first and second element. So we have B transpose A transpose transpose equals to 0, since 0 transpose is still 0. And we try to simplify this a bit. We have B transpose A equals to 0. And now we know we have made the assumption that AX is equal to B. There's a solution, therefore this equation holds. So now we try to multiply both sides by B transpose, and we get B transpose AX equals to B transpose B. And we know that B transpose A is 0. So we know 0x is equal to B transpose B, which then gives us B transpose B is equal to 0. And one fact that we need to know for this proof is that if we have any vector x1 to xn and we multiply it by its transpose x1 to xn, what we get is x1 squared plus dot 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 xn squared, which is the same as x1 to xn inner product itself, which is then equal to the length of x1 to xn squared. So in this case, since B transpose multiply B equals to 0, then B transpose multiply B is also equal to B length squared equals to 0. And the length of B squared is only 0 when B is 0. And that is given in the definition of inner product. The inner product of the same vector will be 0 only if the vector is 0. So in this case, B length squared is equal to 0 only if and only if B is equal to 0. And this is a huge contradiction because in the question we are given that B is non-zero vector. So we have a contradiction since B is non-zero. And if we made the assumption that AX equals to B has a solution, then we come to derive that B has to be equal to 0, which is a contradiction to the question itself. Therefore, the initial assumption that AX plus B has a solution is false. And we can then conclude that AX equals to B has no solution. And this question is quite tricky because you utilize the technique of proof by contradiction. You have to understand that this proof is based on the fact that we are assuming the opposite of what we are trying to prove, and we derive a contradiction. And this contradiction shows that what our assumption is wrong. So what we have assumed is not true. And since we assume the opposite of the thing we are trying to prove, so therefore, since the thing we assume is false, then the opposite will be true. Therefore, we have got what we need, which is ax equals to b has no solution.